All right, so let's take what we've learned about quadratic functions and graphing and the axis of symmetry and the vertex and the y-intercept and all that good stuff and use it to solve a word problem. During halftime of a basketball game, t-shirts are launched into the crowd using some sort of strange device. What is that? A t-shirt is caught 35 feet above the court. How long will it take the t-shirt to reach its maximum height? 2, what is the maximum height? And number 3, what is the range of the function that models the height of the t-shirt over time? So we know that when you launch something into the sky, it goes in a parabolic arc, in an arc that looks like a parabola. So it's going to kind of look like this. If it shoots into the air, it'll go up and it'll go up and it'll go up and then it'll reach its top and then it'll start coming back down. And we know that the t-shirt was caught at 35 feet. So we're going to use what might be called the vertical motion model to solve this problem using parabolas, using quadratic functions. We also know that the vertex of a parabola is the highest or the lowest point. In this case, our parabola is opening down. It's going to have a maximum. So our maximum is going to be the vertex right there. So if we think about this being a graph over time, and this graph line down here being the individual seconds at which things are happening, so 1 second, 2 seconds, 3 seconds, 4 seconds, think about this going over time. We can figure out the answer to our questions. How long will it take it to reach its maximum height? At what point will it be right up here at the top? And then what is that height? And that'll give us an opportunity to think about the range as well. So let's get into it. We are given an equation. The function h is equal to negative 16t squared plus 72t plus 5 gives the t-shirt's height h in feet after t seconds. So you can think about this axis right here, this x-axis being t, and the y-axis here, we can think about that as being h, or the height. Now, if you think about it, you can imagine that the axis of symmetry of this parabola, the point at which we find its middle point, you can imagine that right there, that is going to be the time at which the t-shirt makes its highest point, at which it reaches its vertex. So let's find the axis of symmetry first. Now you remember that to find our axis of symmetry, we're going to use the equation x equals negative b over 2a. It's going to give the x coordinate of the vertex, right there. Our b in this case is 72, so we're going to take the opposite of that, negative 72. And then we'll take 2 times a. Well, in this case, a is negative 16. And then we can punch that into our calculator and find the answer. That is going to give us an x value of 2.25, or 2 1/4. And that is the time at which our t-shirt is going to reach its maximum height. So that's the answer to number 1 right there. So that gives us number 1. But what about number 2? What is the maximum height? Well, we've found the axis of symmetry. We just need to find the vertex. And remember that to find the vertex, we just substitute in the value that we had before for the axis of symmetry into the original equation. So y is equal to negative 16 times the time, which is 2.25, squared, plus 72 times 2.25 plus 5. We just need to calculate that all out. And when you punch it into your trusty dusty calculator, it might look a little something like that right there. Okay? And we hit enter, and the answer is 86. So the vertex, the y component of the vertex, the y coordinate is going to be 86, which means that our vertex itself is going to be 1 and 86. But since that is the y coordinate, that means that it is giving us the height right here. It's giving us the height, the max height of that t-shirt, which is 86 feet. So that is the answer to part 2 right there. Answer to part 2. And now let's just reason together for a moment about the range of the function. If we look over here at the t-shirt, it's being launched from this point right here, and it's going up to the top of its arc and then beginning to come back down. Now the range is all the possible y values that this parabola can have. And we know that on the right-hand side, it ends at 35. So we know it can't, on the right-hand side, it's not going to go any lower than 35. And on the left side, it's starting where it's launched. Now, what value is that? Well, here's an interesting little fact. This last C component right here, this last C piece of my quadratic in standard form, the C is the y-intercept. So in this case, the C value of 5 is telling you the height at which that t-shirt is launched. So it's launched from 5 feet, and then it's going up into the arc, and it's being caught at 35 feet. So what are the possible y values that it can have? Well, it can't have 0 because it starts at 5, and it can't have 1, 2, 3, or 4 because it starts at 5. So we know that 5 is going to be the smallest value that we can have. And we know that y is going to be greater than or equal to 5. But we also know that y must be less than or equal to its maximum height, which is 86. And that is the range of the function that models the t-shirt being launched. 1, 2, and 3.